we're going to be given two different functions, f of x, which is the red function, and g of x, which is the blue function. And we're going to be asked to add them, subtract them, and do various other operations with them. First thing we want to do is we actually want to create some x, y points on each graph then. In other words, we're just going to go look up x points on the red and then on the blue graph and get the y value that corresponds with that. So on the red graph, the f of x, when x is -2, the graph's down here at -1. So that's what we're looking for on the table. When x is -1, it's at a -1/2. By the way, these are counting by halves. So -0.5. And so forth. You're doing the same thing on the blue. When x is -2, it's way up here at 3. When x is -1, it's down quite a bit, but still up at +1, and so forth. Take a moment, complete the table, and you can check your values. Okay, take a look at my values, see if we match. If you're getting something different, stop the video and see if you can figure out why. What we're going to do is actually use these values. We could use the table each time, but since we've made it, or the graph each time, but since we've made a table, it's going to be quicker to do it that way. They want us to add these values, add f of x to g of x, the outputs. So we take our certain inputs. When x is -2, we had a y value for f of -1. We had a y value for g of 3, so we're adding those. We get a value of 2, and so forth with each point. So when I go graph, it's this final answer that I'm going to graph. When x is -2, the combined graph is going to put me at a +2. When x is -1, I'm going to be at +1/2. Connecting the dots as I go. 0 still leaves you at 0, so you'll just plot on top of those. 1 is still 0, so you get a horizontal line connecting across. And at 2, you're up at 2, so you'll actually touch the red graph there. And that's fine. Take a moment and try number 3, where you're subtracting. Here's what I get for number 3. If yours is different, stop the graph, see if there's something that you can find. And if not, make a note of it, and we'll talk about it in class the next day. Okay, so number 3, they want us to multiply. Same thing, you're taking those y values for f and y value for g and multiplying. These are the values that I got. Let's see what that looks like on a graph. When x is -2, we'll go down to -3. -1 takes us to -1/2. Back at 0, 0. When we're at 1, we go to a -1/2. And 2 takes us back to 0. So a lot of that traces along the blue graph. And that's okay. For number 4, they still want us using those y values that we found, but we're going to plug them into this expression. We're going to multiply the g value by 2. We're going to multiply the f value by 3, and then we're going to subtract them. So you can stop the video if you need to and check the values, make sure you're getting those. And then we're going to graph it. At -2, you're way up at +9, so we're not going to be able to graph that one. But at -1, you're at 3.5, so we'll just take that one way up off the graph. When you're at 0, you're still at 0. 1 is a -5, so again, you're going to be way off the graph. And 2 actually takes you a little bit further off the graph. So you're going to have something like that for number 4. Okay. 5, we've got something different going on here. This is not a multiplication problem. Notice on 3, it was a solid dot. This is now an open dot. It's called a composition. When we read this, we say f of g. F composed of g, F made up of g. And what they want us to do, the x value they give us goes into the inside. So that will be F made up of g of -2. So the first thing I have to do is know the value. I can either look it up on the graph or I can go back to my table. But I need the value when x is -2 for the g graph, which is up here at 3. So I'm looking at f of this, replacing this with its actual value, which was 3. So now all I want to know is what is function f's value when x is 3. Now it's a new x. So when x is 3, I can go look on the table, and this time I would have to look on the graph because we don't have this one on the table. So that's actually going to be an outcome of 4. All right? Doing the same thing here. F made up of g of -1. We're just using the x values that they gave us here. So what that means is find the f value for whatever this y value is. When x is -1, g's up here at 1. So this is really f of 1. So I'm coming to 1 on the x-axis and going to my f graph, which is actually a 1. Then I want f of g of 0. Again, this is this value that I'm plugging in. We know when you're at 0, g has a value of 0. So that's f of 0. And when x is 0, the red graph is also sitting at 0. So that one stays 0, 0. When f has a g value of g has a 1 plugged in, its value then is what we want. When x is 1, g is down here at -1, so this is f of -1. When x is -1, f is a -1/2. Finally, f of g of 2 is what we're looking for. So we go to the x value of 2 and look at our g graph, the blue. That has a value of 0. So it's f of 0 that we want to really know. When x is 0, my red function also has an output, a y value of 0. And we can go graph those. That will wind up then looking like -2 is up at 4, -1 is at 1, 0, 0. 1 is at -1/2, and then you're back at 0. Alright? So we're going to do the same thing, but in reverse. This is g made up of f. So we'll do g of f of -2. And that one winds up being, when x is -2, the f graph is a -1. So that's really g of -1, which gives us an outcome of 1. I can look that up on the table, or I can go -1 and go to my g graph. Then I want g of f of -1, which is really g of -0.5. That's not on my table, so I am going to have to use the graph. When x is a -0.5, what is the g value? Well, that's a positive 0.5. That's my output, 0.5. Then I want g of f of 0. Well, f of 0 has a y value of 0, so I want g of 0, which is also 0. This particular setup of graphs, 0 always gives you 0. That is not true with every graph. Now x is 1, so I want g of f of 1. When x is 1, my f value is also 1. So that means I want